Assalamu alaikum. Welcome to lecture 16 of data mining. So today we will start discussing clustering in more detail. We had started talking about similarity functions and measures last time. So we'll start from there today and then move on to discussing the types of clusters and clustering algorithms, and then starting with one of the first clustering algorithms, which is the k-means clustering algorithm. So that is basically the agenda for today. Uh, So we are done with more than half of the semester, so less than half of the semester is remaining. So we still have to cover clustering, outlier analysis, and some additional topics. All right. So then let me get started. So we were talking about clustering. We had introduced clustering. So clustering is the process of grouping data objects such that objects within a group are similar to one another, and objects between groups are dissimilar. So a important keyword in this definition is similarity. So we need to have a way of quantifying the similarity between two objects or two observations. So that is done by a proximity function slash, by the way, proximity function is one name, but it's also known by many other names. For example, distance function, similarity, dissimilarity, and so on. So the purpose of this function, let's say we are talking about dissimilarity or distance function, that would be a function d. So this function d given to objects which are described by vectors x, let's say object 1, x1, and object 2 x2. So this would quantify the dissimilarity or distance between these two objects. So this is going to be a scalar value. Say it's going to be a single value, which would give us the dissimilarity between these two objects. So now let's quickly go over the uh, various distance functions or dissimilarity functions. So first of all, let's think of objects that are described by numeric attributes. So we have m attributes. All of them are okay. So each object, each observation, each example is described by m attributes. All of them are numeric, meaning that the vector x that I wrote above is a vector of size m. And each of those elements in the vector is a scalar real number. Okay? So the most common measure or the most general measure for this is the Minkowski distance. We talked about this last time. Okay? The Minkowski distance, uh, so basically this is defined, if I want to write this, so x1, x2. So we have a summation. I'm going to write it in terms of elements. On the left-hand side, x1 and x2 are vectors. On the right-hand side, I'm going to use two indices. Those would be elements. So let's say I, let's use j. J is equal to 1 to m. Okay, so this is a summation. And then we have the operation here, x 1 j minus x 2j. So these are elements. raised to power of p raised to power of 1 over p. So this is the formula for Minkowski distance. Uh, there are two important specializations of this distance. One is called the Manhattan distance. Here p is equal to 1, meaning that in the formulation above, we take the absolute differences of elements at each position and sum them up. So we raise it to power 1 and we take the uh, in square root to the power, so the root to power 1, which is actually we don't take any root. Okay, so this is the Manhattan distance. And then we have the Euclidean. Here d is equal to 2. So this is the straight line distance. So if I want to show you, so if we have object described by two numeric values, meaning that they can be represented by points in the plane. So if you have a point here, this is one x, this is another x. Euclidean distance would be this distance, the straight line distance. Okay? So Euclidean distance is the straight line distance between the 2 points when plotted in m-dimensional space. So the Manhattan distance is the block distance between the 2 points in m-dimensional space. So let's say if you have x here, you go, this is 2D, so just have 2 steps and this way. So this would be the sum of this distance would be Manhattan. So Manhattan distance is a block distance and Euclidean distance is a straight line distance. And the Minkowski distance in general would be a distance that would be defined by some line that connects the 2 points in m-dimensional feature space. Okay? So of with 1 you have straight line block distance, with 2 you have straight line. So if you have a value between of p between 1 and 2, that distance would be uh, some curve that is between the block distance and the straight line distance. But at least in data science, we don't use point values for p. We stick with p is equal to 1, which is Manhattan, or p is equal to 2, which is Euclidean distance. Okay? So the left-hand side is Euclidean distance, the right is block distance or Manhattan distance. So some distance measures or distance functions are also called metric. Uh, and sometimes people use this term metric loosely, but to be precise, when a function, when a distance function is metric, it has to satisfy some conditions. So those conditions are now as follows. So the distance between 2 points x1 and x2 should always be greater than equal to 0. Okay? So that is one condition. The dissimilarity between the two objects should be greater than equal to 0. And the dissimilarity between x1 and x2 would be equal to 0 if x1 is equal to x2, meaning that this is the only situation where the distance between the two would be 0, meaning that they're the same points, meaning that they're the same object, they're the same observation. Okay? So this is the second condition. And the third condition is popularly known as the triangular inequality. The distance between 2 points x1 and x2 should always be less than equal to the distance, the sum of two distances of x1 to some other point x3 plus d x3 to x2. Okay? So this is particular condition is called the triangle So if a distance function follows all of these conditions, then we say that it is a metric. ठीक है? Uh, so in data mining, in data science, it is preferred that our functions are metric, but it is not essential. Uh, Obviously, if a function is metric, then it will give consistent results all the time. Consistent meaning that you won't have any inconsistencies with respect to the similarities. But if you don't have a metric, then you can still apply most of the algorithm that we'll discuss. But then you need to be aware that there may be issues in the results and you need to be carefully interpreting them. So by the way, the triangle inequality is easily verifiable. So let's say if you have x1 here, this is x1, and you have x2 there. Uh, so if you have x1 here and you have x2 here, if you have an x3, as you can see, this distance will be greater than this distance. Here I'm talking about Euclidean distance. The distance directly between x1 and x2 is less than the distance between x1 and x3 and x3 and x2, the sum of the distance between that. So this is, of course, the triangle inequality. Okay, so now let's talk about binary attributes, meaning that all attributes are binary. So what are binary attributes? You have 0, 1 only, or MF, or whatever, only two possible values for each attribute, and you have M attributes in general, all of them being binary. So the most common way to quantify the similarity between two observations, the two objects that are described by binary attribute, is called the simple matching coefficient. We talked about this before as well as part of association mining. Okay? So basically this is number of matched values divided by M. M is the total number of values in each observation. So for example, just a quick example, let's say you have uh, two patients and both patients are described by the values of three tests. So test 1, test 2, test 3. So let's the first patient is 1, 1 and 0, and let's say the second patient is 0, 1 and 0. Okay? So the similarity would be what is the matching between the two? So there are two matches. So 1, 1 matches and 0, 0 matches. And total number of attributes is what? 3. This will be 2 over 3. So by the way, this is a similarity. Okay? So if you wanted to compute dissimilarity, then it would be 1 minus SMC. So this would be dissimilarity. Okay? In some applications, a match of uh, values that are both 0 or some other value that is considered less important is discarded. So one of those applications, although it's not always done, but one of those applications is medical test. So in the example above, so we will not count the matches of 0, 0. So we will only count the match of 1, 1. So in that case, SMC would be basically 1 over 3. ठीक है? So we call such binary attributes as asymmetric. So one value is more important than the other value. In this case, the value of 1 is considered more important than the value of 0, and a match of 1 is counted and a match of 0 is not counted. ठीक है? Of course, this is all domain dependent. You as a data scientist would need to decide which whether you want to do this or you want to count all matches. All right. So that was the case when you had uh, binary attributes. So let's say if you have in general categorical attributes, all M attributes are categorical. So in general, binary is also categorical, but here I'm putting it as a separate uh, field because categorical attributes may have more than one possible value for each attribute. So you can have, for example, gender and job rank. We have been looking at this category for a while now. So gender is binary and obviously job rank is multi-valued. So you have M and let's say job rank is AM, and then you have let's say M and job rank is SM. Here again you simply use the simple matching coefficient. The same approach will be used. So in this case it will be 1 over 2. So MM matches, AM and SM do not match. Here of course we don't have a notion of asymmetry or symmetry. Okay. So again, within categorical, you may have attributes that are ordinal. So categorical attributes can be nominal as well as ordinal. All M are ordinal, let's say. So what do you do now? Ordinal attributes have values, have rank or order. Okay. So let's say I take a simple example. Let's say एक तो आपके पास rating का ले लेते हैं rating which is ordinal and any other let's say grade is also ordinal. ठीक है. तो रेटिंग लेट्स से रेटिंग की 1 2 3 4 and 5. ठीक है. So these are labels, they are categorical, but we can give them numbers since they are ordered. ठीक है. 1 rating is less than 4 and 4 is less than 5, but we cannot say whether 1 and 2 का difference वही होगा जो 2 और 3 का होगा. We can't say for that absolutely. Similarly, grades की भी इसको हम कह देते हैं A, B, C, D and F. ठीक. So in this case, let's say you have two examples, two observations. तो एक की रेटिंग 3 थी, उसका ग्रेड A था. ठीक है. और दूसरे की रेटिंग 4 थी, उसका ग्रेड B था. ठीक है. So what we do is, since both attributes are ordered, so we can consider each attribute separately and compute its uh, difference. So for the first attribute, which is rating, ठीक है. तो फर्स्ट एट्रीब्यूट का क्या होगा? 4 minus 3, difference is 1. And how many possible values do we have? 5, right? So let's say एक वैल्यू 5 हो सकती थी, दूसरी वैल्यू 1 हो सकती थी, उस डिफरेंस मैक्सिमम 4 था. तो ऑब्वियसली मैक्सिमम डिफरेंस 4 हो सकता है, सो वी आर डिवाइड बाय 4 टू गेट ए टू नॉर्मलाइज इट. ठीक है. 4 minus 3 divided by 4. ठीक है, so that's 1 over 3, 1 over 4.25. This is for the first attribute. For the second also, you can do the same. So again, A and B have a difference of 1. Give them ranks. Of course, as I said, in general, we do not know okay, the difference between A and B should be equal to the difference between B and C. But in this computation, we assume that they are the same and we give them some small rank values. So it may be B minus A would be basically whatever 2 minus 1 divided by 5 values, इसमें भी 4 ही होगा, ठीक है, 0.25. And then of course you can take the average of the two or the weighted average if you want, if there is some way of combining the two attributes. So overall, this is by the way dissimilarity. So this would be then, if you just want to take the average, 0.5 into, so we have 0.25 plus 0.25 give you 0.25. Okay. Of course, you can take the weighted average as well if you feel that one attribute is more important than the other, then you might give it more weightage. For example, 0.6, 0.4 rather than 0.5, 0.5. Okay. By the way, this weighted approach you can use for all the other techniques as well, including the Euclidean distance and Manhattan distance. So in general, for any attribute that has k possible values, you convert that into ranks, and then basically simply uh, rank of uh, the first attribute. Uh, so rank of the first observation, let's say 1 minus rank of 2 divided by k minus 1. So this would give you the distance or dissimilarity between the two observations for that attribute. If you have multiple attributes, you need to combine them. Take the average. Okay. So far, we have talked about observations or objects that are described by attributes of the same type. They were either all numeric, all binary, all ordinal. So now what about if you have attributes that are mixed type? So let's say you have attributes that are numeric as well as categorical as well as binary. You can use this approach very similar to the one that I mentioned for ordinal. So you can consider each attribute separately, compute its similarity or dissimilarity according to the most appropriate for that type of attribute, and then take the average or weighted average for all the attributes. So, so just to take an example, let's say एक आपके पास age है which is numeric, let's say, उसके बाद gender है which is binary, उसके बाद let's say color है which is you can say uh, categorical more than 2 values. ठीक है? So age let's say 50 है, gender M है, and color let's say red है, और age 55 है, और gender let's say female है, और color फिर let's say blue है. ठीक है? So you will consider each attribute separately. अब numeric attributes की क्या करेंगे? For numeric, so basically for numeric, you basically take the difference of the two and divide by the maximum possible distance from the data set. So this would be 55 minus 50. By the way, मैंने बड़ा वाली वैल्यू पहले लिखी, तो आप इसको एब्सोल्यूट भी ले सकते हैं. ठीक है, पॉजिटिव वैल्यू चाहिए हमको, डिस्टेंस है, डिस्टेंस कैन नेवर बी नेगेटिव. ठीक है, डिवाइडेड बाय बेसिकली मैक्स एज माइनस मिन एज. मतलब आपके इस डेटा सेट में जो मैक्स वैल्यू थी, जो मिन वैल्यू थी, ठीक है, उससे डिवाइड करेंगे. सो दिस विल गिव यू द डिसिमिलरिटी फॉर दिस एट्रीब्यूट. सिमिलरली बाइनरी है आपके पास. तो लेट्स से मैं इसको कोई नंबर दे देता हूँ. लेट्स से अगली लाइन पे चलते हैं. 5 डिवाइडेड बाय लेट्स से मैक्स था आपके पास 70 और मिन था लेट्स से 10. सो आपके पास ये वैल्यू आ जाएगी. ठीक है। तो नेक्स्ट था जेंडर। सो जेंडर में डिस्टेंस 0 है, दोनों मेल मेल हैं। ठीक है। और कैटेगोरी, जो कैटेगोरियल सिम्स वी आर नॉट कंसीडरिंग ओनली व्हेन एट्रीब्यूट डिस्टेंस विल आइदर बी 0 और 1। तो जेंडर का डिस्टेंस 0 है और उसका डिस्टेंस 1 है। सो फॉर जेंडर द डिस्टेंस इज 0। ठीक है। सो फॉर तीसरी क्या चीज थी हमारे पास? सो जेंडर के बाद कलर, distance is d is equal to 1, so simply now take the average of the three। so आप क्या करेंगे, तीन एट्रीब्यूट्स हैं, 0.833 है, 0.833 प्लस 0 प्लस 1 डिवाइड बाई 3। ये आपके पास आ जाएगा फॉर दीज टू ऑब्जर्वेशन। सो मिक्स एट्रीब्यूट्स आप इस तरह हैंडल कर सकते हैं। ऑफ कोर्स हियर वी हैव गिवन इक्वल वेटेज टू ऑल एट्रीब्यूट्स। You can use some other weighting scheme if you feel it is appropriate for your data set। ठीक है। सो So a special case of all numeric attributes. So we talked about numeric attributes and we talked about Minkowski distance, for example. So all numeric attributes also arise in textual data sets. Uh, so for those, the cosine similarity is commonly used. It's a similarity, not a dissimilarity. The cosine similarity, let's say we have the two vectors x1 and x2, would be the inner product of the two vector x1, x2. Inner product क्या होता है? एक vector as a row multiplies with the other vector as a column, scalar value आ जाती है, then divided by the length of the two vectors, length of vector x1 up to। ठीक है। So this is a cosine similarity, this value would range between 0 and 1। 0 means that they are dissimilar, 1 means that they are similar, identical। So ये भी use होता है if you have all numeric attributes describing the and this is, as I said, is more appropriate for text processing as well as textual content। Uh, so there may be other similarity measures as well. So you can use any that is appropriate for your problem. For example, let's say if you're doing uh, string clustering क्या होता है? Characters clustering, so you can use the edit distance। Edit distance for those who studied NLP, आपको पता होगा edit distance क्या है। So you can compute the edit distance between two strings। तो वो भी आप यूज कर सकते हैं। So this would be a dissimilarity function, proximity function for strings। ठीक है। सिमिलरली आपकी डोमेन बायोइन्फॉर्मेटिक्स की, आप बायोइन्फॉर्मेटिक्स को सिमिलरिटी मेजर यूज कर सकते हैं। कोई सोशल साइंस की है तो उसकी आप यूज कर सकते हैं। फाइनली समटाइम्स यू कैन आल्सो क्रिएट ए डिसिमिलरिटी मैट्रिक्स। ठीक है। सो सो रिमेंबर वी टॉक्ड अबाउट वन ऑब्जर्वेशन एज अ वेक्टर एक्स आई, ठीक है, of size m। So if you have size m, meaning that you have m features, if you have n observations, you get a data matrix। Data matrix capital X। So this would be of size then n number of rows, which is the number of observations multiplied by m number of features। ठीक है। सो पेयर वाइज सिमिलैरिटी हर टू एट्रीब्यूट्स के आप निकाल के एक मैट्रिक्स में डाल सकते हैं, एंड दैट मैट्रिक्स इज कॉल्ड द डिसिमिलैरिटी मैट्रिक्स. आप you can use the function that we discussed above to do it, or you can ask humans to fill in. So for example, आपके पास n था, तो you'll get n by n dissimilarity matrix. तो उसका जो पहला एलिमेंट होगा, फॉर एग्जांपल दिस मैट्रिक्स, लेट्स से मैं कहता हूँ d है ये, तो d 1 1 would basically be the dissimilarity between x1 and x1. Of course, this would be 0, right? Similarly, D matrix 2 1. अब मैं आगे जा रहा हूँ रो पे. So this would be the distance between x2 and x1. And similarly, D 1 and 2 would be D x1 x1 and x2, and so on. अच्छा, एक चीज मैंने मैट्रिक में पीछे पीछे मैट्रिक डिस्कस किया था ना. द मैट्रिक, ए फंक्शन दैट इज मैट्रिक, वो जो कुछ कंडीशन लिखी थी, ये कंडीशन भी एक है, डी एक्स सिमेट्री वाली, डी एक्स वन एक्स टू in general should be equal to d x2 x1. This is basically symmetry. So metric की conditions क्या है? Symmetry है, triangle inequality है, और greater than equal to 0 है. Equal to 0 only when x1 is equal to x2. So these are the three conditions. तो पीछे ये वाली मैंने लिखना. So if it is metric, then obviously this similarity matrix would be symmetric also. ठीक है? Because जो matrix element 1 2 would be similar to the value at 2 1, and in general for any two values that are at the same position across the diagonal. ठीक है, तो this similarity matrix is symmetric. So, आपके पास कुछ इस तरह का मैट्रिक्स आएगा. दिस इज द होल मैट्रिक्स. स्क्वायर मैट्रिक्स होते हैं n बाय n, जो डायगोनल है इस तरह है, तो यहाँ की वैल्यू वुड बी सिमिलर टू यहाँ की वैल्यू across the diagonal. Okay. Of course, if this would be the case if you are using a function that is a metric. But ये matrix जैसे मैंने कहा है, you can ask humans to fill it out for you. For example, आपके पास एक ऑब्जेक्ट 1 है और ऑब्जेक्ट 5 है, उसके मतलब फर्स्ट रो में फिफ्थ एलिमेंट पे आप किसी डोमेन एक्सपर्ट से पूछें कि सिमिलैरिटी क्या होगी, ही सेज दैट 0.8 या 0.8 लिख दिया. और लेट्स से इसी ऑब्जेक्ट की विद सिक्स वो कहता है 0.5 है, तो वहाँ 0.5 लिख दिया. सो यू कैन फिल आउट द एंटायर मैट्रिक्स इन दिस वे. Okay, so that I think would bring us to the end of discussion on similarity and dissimilarity or proximity. So we talked about various functions as well as some conditions for it to be a metric. We also discussed the dissimilarity matrix, where you can fill in all the values at once for all the observations in your data set. So now let's move back to clustering. So before starting a clustering algorithm, let me categorize clustering. And categorization of clustering can be done in different ways. So let's start first with types or categories of clusters. ठीक है? So clusters can be, I'm going to write some different categories here and then explain them briefly. Proto, type based, density based, or graph based. So this is one categorization of types of cluster. ठीक है? So let me explain this. So prototype based means that you are describing a cluster by some observations or some object in that cluster. ठीक है? It could be one or more. ठीक है? So some representative object within the cluster. So let's say आपके पास ये cluster है, मैंने उसका क्लाउड बनाया है, तो इसका एक रिप्रेजेंटेटिव ऑब्जेक्ट एक लेना तो एक बीच वाला कोई ऑब्जेक्ट होगा, लाइक ए मीन और मीडियन और मोड. 2D में ये प्लॉट किया हुआ है मैंने. सो दैट इन दिस केस ये some object that's in the center of this cloud. So this would represent this cluster. If your clusters are represented by some observations or some point, then it's called prototype based. Sometimes हम multiple से भी कर सकते हैं. तो लेट्स से ये मेरे पास एक कॉम्प्लिकेटेड सा था, तो एक मैंने इधर ले लिया, एक इधर ले लिया और एक इधर ले लिया. सो आई कैन रिप्रेजेंट दिस क्लस्टर बाय 3 ऑब्जेक्ट्स. दिस इज लेस कॉमन. या आप कह लें कि यू स्फेरिकल था तो बाउंड्री पे आपने सारे ऑब्जेक्ट ले लिए और सेंटर में ले लिया. इंस्टेड ऑफ टेकिंग ऑल द ऑब्जेक्ट्स इन द क्लस्टर, वी रिप्रेजेंट a cluster by some selected objects that represent the cluster in a appropriate way. The most common, as I said, is the centrally located object or point in the cluster. Okay? So if you represent clusters with points or observations, then we call it a prototype based cluster. So this is prototype based. Okay? So the next is end of slide show again. Okay. Okay, so the next word, density based. Density based, as the name suggests, is you represent a cluster by the density of the observation. So for example, इस जगह पे बहुत सारे आपके पास ऑब्जेक्ट्स हैं, so this represents a cluster. एक और जगह पे आपके पास ऑब्जेक्ट थोड़े से ज्यादा स्प्रेड आउट हैं, दिस आल्सो रिप्रेजेंट ऑब्जेक्ट. इधर ऑफ कोर्स इसकी डेंसिटी थोड़ी है, उधर डेंसिटी ज्यादा है. So to represent an object by density, you need to have all observations as well as the volume in which those observations lie. फिर ही डेंसिटी निकाल सकते हैं ना. डेंसिटी किस तरह होती है? So density basically number of objects divided by volume. ठीक है ना, इस तरह डेंसिटी निकले. वॉल्यूम ऑफ कोर्स इन 2D would be area. So if your clusters are based on density, then you need to know all the objects as well as the area in which they lie or volume in which they lie. So this is called density based clusters. And then finally we have graph based clusters. So graph based clusters are actually very similar to density based clusters. आपको सारे objects चाहिए, but we also quantify the similarity between every pair or some pairs of objects. So for example, ये कुछ objects हैं, तो आपने इसका कोई ग्राफ बनाया हुआ है, उसके बेसिस पे उसके मैट्रिक से आपने डिफाइन किया ये क्लस्टर. ठीक है. एंड ऑफ कोर्स सिंस ये मैंने अब ड्रॉ किया हुआ ऑन स्केल 2D पे, तो ये इफ 2 पॉइंट्स आर फार अवे तो इनका ये लिंक होगा तो सही, बट सिंस डिस्टेंस इज हाई, इसका मतलब ये दूर है, वाइल ये मैंने 2 पॉइंट्स बनाए ये करीब है. सो आपने कोई ग्राफ नोशन लेनी है टू डिफाइन ए क्लस्टर. ठीक है, विच इंक्लूड्स लिंक्स एंड नोड्स and some other metric that would somehow quantify the closeness of those nodes in some space according to the links between them. So typically clusters according to this categorization are of 3 types: prototype based, which is the most common, and then we have density based, which is also used, and then graph based, which is also used. तो ग्राफ और क्लस्टर्स क्लस्टर्स आप इस तरह डिफाइन कर सकते हैं. Another categorization of clusters is hard और soft. ठीक है. So basically this means that hard clustering में होता है every object must be in one and only one cluster. ठीक है. So one object cannot be, so this is hard cluster. So one object cannot be in multiple clusters. It can only be in one cluster. And of course, if you can allow clusters to be in multiple objects to be in multiple clusters, that would be soft clustering. So soft clustering में typically probabilistically होता है कि we say that cluster for object X so belongs to cluster C1 with probability 0.6 and it belongs to C2 with probability 0.4. ठीक है. तो हमने एक को exclusively assign नहीं किया X. We assigned it to both C1 and C2. So this would be soft clustering or soft cluster. ठीक है. Okay. So this was, there are actually other types of clusters as well. I won't go into that. So now let's briefly talk about types of algorithm. Or here, of course, I will mention them. So we have partitional, we have hierarchical. So these are the two main types of clustering algorithms. Although आप further categorization भी कर सकते हैं. जैसे उस कैटेगराइजेशन में लोगों ने डेंसिटी बेस्ड भी इसमें रखा हुआ है, ग्राफ बेस्ड भी इसमें डाला हुआ है, and there may be others as well. For example, model based. So this is the categorization of clustering algorithms. कि algorithms किस तरह चलते हैं, उनकी characteristics पे ये categorization बनी हुई है. Partitional and hierarchical are the two primary categories. Additional categories मैंने आगे लिखी हुई हैं. So we will discuss this shortly. And one other thing, you can have types of clusterings. या वो clustering algorithms में ही डाल सकते हैं. Okay. So तो clustering algorithm की types एक और मैं लिख लेता हूँ, although this can be categorized something else as well. So we can say that we have a global clustering algorithm or a local clustering algorithm. And this is more tied with the clustering algorithm because it depends on कि जो उसका goal था algorithm का, was it global, was it making a decision based on all the data at once, or was it making a decision at only looking at a small subset of the data? If it was looking at all the data, then it would be global. If it was looking at only small amount of data, then it would be local. तो इसमें of course optimal और सब optimal के concept भी आ जाते हैं. तो आई थिंक इसको हम आगे जब एल्गोरिथम डिस्कस करेंगे वहां भी ये चीजें आएंगी. सो लेट्स नाउ मूव ऑन टू द एल्गोरिथम्स. वन अदर कमेंट, क्लस्टरिंग के लिए आई वुड स्ट्रांगली सजेस्ट कि आप in addition to Han's book, you should also read the relevant chapter of the other book, which is the book by Intro to DM book. वो भी पढ़ें आप. दोनों बुक आपने पढ़नी है. इंट्रो टू डीएम बुक इज एक्चुअली रिटन इन अ बेटर वे. तो वो काफ़ी डिटेल में है और कुछ चीज़ें ज़्यादा क्लियर भी हैं उधर. एंड ऑब्वियसली सो ओके, सो आई वुड सजेस्ट कि ये चैप्टर एटलीस्ट आप दोनों बुक से पढ़ें. आई बिलीव ये जो चैप्टर इंट्रो टू डीएम का चैप्टर क्लस्टरिंग का इट इज़ फ्रीली अवेलेबल, आप गूगल सर्च करेंगे तो ये डाउनलोडेबल पीडीएफ है, अवेलेबल है, बुक की वेबसाइट से अवेलेबल है। ओके, नाउ लेट्स गो बैक टू आवर पार्टीशनल। ठीक है, so partitional algorithms are, so first of all let me write the settings. So we have n objects or observations which we want to cluster. In partitional algorithms, we will need to specify k clusters. So k needs to be specified upfront. ठीक है? And obviously k would be much less than n, right? Cluster ढूंढने ना आपने, तो clusters k, the number of clusters would be much less than the total number of observations. Otherwise, would defeat the purpose. Okay. ठीक है? So the partitional algorithm recursively, uh, okay, not recursively, partitional algorithms basically would then output clusters, would divide the data set into those k clusters, and these algorithms usually uh, kind of minimize or optimize an objective function. ठीक है? Implicitly or explicitly. And this objective function obviously would be based on the notion of similarity. So we would like to maximize similarity for objects within a cluster, and we would like to make sure that objects between clusters are of low similarity. ठीक है? So इसमें जो हम पहला एल्गोरिथम डिस्कस करेंगे, which is called the k-means algorithm, which is the most popular clustering algorithm. So k-means algorithm is partitional. ठीक है? अब इसकी करेक्टरिस्टिक लिख रहा हूं मैं, पार्टिशनल है। सेकेंडली इट इज प्रोटोटाइप, it uses the notion of clusters as being described by prototypes, and in this particular case by the single point which is the mean of all the objects within the cluster. ठीक है? So it's partitional, it is prototype based, and also it is uses an objective function. ठीक है? So since it uses objective function, it's actually solving optimization problem. ठीक है? To find those k clusters. So k is required as input. ठीक है? We need to know k upfront. So first of all, let me describe the process, and then I will write the objective function, which is actually minimizes through that process, and then we will discuss some of its characteristics. Uh, okay, so let me see. Okay, I can do it with 1D. So let's say if you have a data set that is 1D, meaning that just numbers. So आपके पास है 5, 5, 8, 10, 12, 12 and 15. ठीक है, तो how many points do we have? 4, 5, 5, 8, 10, 4, 5, 6, 7 है. चलें 7 ले लेते हैं. So n is equal to 7 and let's say k is equal to 2 मैं करना चाह रहा हूँ. ठीक है, I want to find two clusters. So I'm going to describe the process through this very simple example. So we start with selecting two prototypes or two means. In this case, the prototype is the mean. तो वो हम कुछ भी ले सकते हैं. It could be done randomly. Of course, we will see later on कि आप कुछ more advanced techniques भी use कर सकते हैं, but it can still work with random. So let's say मैं कहता हूँ कि let's say मैं एक 10 ले लेता हूँ. ठीक है, और एक ले लेता हूँ मैं 14. Assuming कि I, by the way, ये point होता है. You can take an object, but in general it can be a point in that space. ठीक है, so it's not necessarily 14 जैसे object नहीं है इसके अंदर, but let's say मैंने एक point ले लिया 14. So my first cluster is described by 10 cluster. ठीक है, this is my cluster 1. अब इसको मैं assign करूंगा. I will assign other objects that are the most closest to this object. So हम चेक करूंगा कि 5, पहला ऑब्जेक्ट उठाया 5, is 5 closer to 10 or to 14. ठीक है, so 5, अब यहाँ सिमिलैरिटी फंक्शन आएगा. तो 10 माइनस 5 यहाँ सिंपल 1D है, तो वेरी सिंपल सिमिलैरिटी डिस्टेंस फंक्शन बन गया. तो 5 है, सो 10 माइनस 5 इज 5 एंड 5 माइनस 14 इज 9. इसका मतलब है कि क्लस्टर 5 क्लस्टर 10 में आएगा, इस क्लस्टर में आएगा. इसको मैं बेसिकली C1 कह देता हूँ. तो दूसरा 5 भी इधर ही आएगा. सो व्हाट अबाउट 8? 8 माइनस 10 2 होता है. 8 माइनस 14 ऑब्वियसली ज़्यादा है, तो 8 भी इधर आ जाएगा. 10 माइनस 10 ऑब्वियसली 10 है, इसके साथ ही आएगा. 12 माइनस 2 जो है, 12 माइनस 10 2 होता है, और 12 माइनस 14 भी 2 होता है. सो ये टाई आ रहा है. सो इट्स अप टू अस को हमने इसको कहाँ डालना है. लेट्स से मैं इधर डाल देता हूँ. ठीक है, अब 14 कोई है नहीं. 15 माइनस 14 1 है, और 15 माइनस 10 ज़्यादा है. तो इसका मतलब है कि जो 15 14 क्लस्टर है C2, उसमें सिर्फ 15 आ रहा है. ठीक है, सो वी नाउ हैव टू क्लस्टर्स. C1 में हमारे पास सारे ऑब्जेक्ट्स आ गए, C2 में एक आया. ठीक है, अब हमने ना, अब जो क्लस्टर्स आ गए, हमने इनका नया प्रोटोटाइप ढूंढना है. प्रोटोटाइप इन दिस केस इज द मीन, सिंस ऑल दीज आर न्यूमेरिक वैल्यूज. तो हम इसका मीन निकालेंगे. 5 + 5 + 8 + 10 + 12 डिवाइडेड बाय 4 5 है. 8 इज द न्यू मीन. इसका मीन ऑफ कोर्स 15 ही है, एक ही पॉइंट है. ठीक है,
सर एक क्वेश्चन है.
सो नाउ यू रिपीट द प्रोसेस नाउ. ठीक है, अब आपके पास जो 8 क्लस्टर है, दिस इज C1. इसमें देखें कौन सा आता है. 5 ऑब्वियसली कम्स हियर, 5 ऑब्वियसली कम हियर, 8 ऑब्वियसली कम्स हियर, और 10 आ गया इधर. ठीक है, तो एक्चुअली सारे इसमें आ जाएंगे. 15 है उधर, लेट्स सी. तो ये 10 है. 12 और 8 का डिस्टेंस क्या है? 12 का 8 का डिस्टेंस 4 है. 12 और 15 का डिस्टेंस 3 है. ठीक है, सो 12 इधर नहीं आएगा. ठीक है, एंड देन वी हैव 15 क्लस्टर. दिस इज C2. सो यहाँ आपके पास ऑब्वियसली 12 आ गया. और 15 आ गया। ठीक है, अब फिर से आप मीन निकालेंगे। 12 और 15 का मीन क्या है? 13 3 है। 1.5, 13.5, 13.5। इसका मीन निकाल लेते हैं। 5 + 5 + 8 + 10 डिवाइड बाई 4, तो ये 7 हो गया। तो ये रिपीट नाउ। ठीक है, सो वी हैव नाउ 7 क्लस्टर। मतलब 7 मैं इसलिए लिख रहा हूँ टू आइडेंटिफाई द क्लस्टर। रिमेंबर प्रोटोटाइप है। दिस इज कॉल्ड C1। अब हमारे पास 5 इसके अंदर आएगा, 5 इसके अंदर आएगा, 8 भी इसके अंदर आएगा। राइट। 10 और 7 3 है, और 10 और 13.5 3.5 है, तो 10 भी इधर ही आ रहा है। ठीक है, 10 भी इधर ही आ रहा है। राइट। 10 13.5 इज राइट, सेम है ना? या सो नाउ वी गो टू द 13.5 क्लस्टर विच इज C2। इसमें आपके पास 12 आ गया और इसमें 15 आ गया। So you notice that from this iteration to the previous iteration कोई change of clustering नहीं हुई। So that's where we stop. ठीक है, so we have the final clusters. Clusters में क्या है? पहले में C1, तो 5 5 5 8 और 10। और C2 उसमें क्या है? 12 और 15। ठीक है, so essentially this is the uh, K-means clustering algorithm. I have demonstrated it with 1D points. If you have in general m dimensional points, so it will work the same way. The only difference would be that the distance would be computed by some appropriate distance, usually the Euclidean distance, and the mean would be the mean of a vector. So let's say 2D है, let's say एक ऑब्जेक्ट में C1 में 3D ऑब्जेक्ट्स हैं तीन, तो 1 1 और 1, let's say दो हैं, 2 1 और 1। ठीक है, अब आप इसका जो मीन निकालेंगे वो किस तरह निकालेंगे? हर एक एलिमेंट वाइज निकलेगा। सो पहला क्या है? एक सेकंड। तो ठीक है, सो पहला का हो जाएगा 1.5 और दूसरे 1 और 1 रहेंगे। 2 + 1 2 डिवाइड बाई 2 1.5। तो ये मीन होगा इसका, वेक्टोरियल मीन। ठीक है, एंड ऑफ कोर्स इफ यू हैव वेक्टर्स ऑब्जेक्ट, तो डिस्टेंस आपका यूक्लिडियन डिस्टेंस या मैनहट्टन या वट एवर डिस्टेंस, बट इट शुड बी a scalar value as distance is always scalar. ठीक है, so let me now in rough pseudocode write the algorithm. So what is the algorithm? So you have uh, n, so you basically have data set n observations. ठीक है, and k clusters, this is an input or this is required. ठीक है, so after this basically you have this process uh, k, ठीक है, and then you repeat। ठीक है, assign each object to the nearest mean, then of course compute the new mean of each cluster। ठीक है, until no change in clustering। So in pseudocode it's just 3 4 5 lines, not very difficult। So you have to repeat two steps। एक step assignment का step है, दूसरा step जो है वो basically मीन कंप्यूटेशन का है, ठीक है। And through this process, we are actually maximizing or minimizing an objective function. And this process actually is a technique or general technique for optimization, which is basically called expectation maximization. उसकी डिटेल में हम नहीं जाएंगे, but ये जनरल टेक्निक है which has two steps, expectation step and a maximization step, ठीक है। सो इसमें जो मैक्सिमाइजेशन स्टेप होगा वो असाइनमेंट है, और जो जो एक्सपेक्टेशन स्टेप है वो मीन कंप्यूटेशन है, ठीक है। All right. So now let me talk about the objective functions. What is the cost function or objective function? So actually this function minimizes or has this cost function that it actually minimizes. Okay. Notation मैं सोच रहा था. So sum I is equal to 1 to n, ठीक है. And we have another summation j is equal to 1 to k, ठीक है. And then we have this summation here, distance function. I'm writing in terms of distance function d object I, right? Sorry, x object I, and then m, the mean of cluster k. वो इसका मैं j का था, j, ठीक है. So if you are using the Euclidean distance, अब खैर अभी मैं distance ही सिर्फ लिखता हूँ, but इसमें I will have to add an indicator function here, I k multiplied by d, ठीक है. So d of course is the where, of course you know x I is object I, mk is mean of cluster j, ठीक है.
सर स्टूडेंट्स के कुछ क्वेश्चंस थे, उन्होंने चैट में शायद
I
पूछा है.
ik is an indicator function. So this function is 0. So I j k तो था नहीं actually, j.
सर स्टूडेंट्स के ना कुछ क्वेश्चंस थे, वो चैट में शायद उन्होंने पूछा है.
एक सेकंड. ये k नहीं है, j, ठीक है. So this is equal to 0 if object I is not in cluster j, ठीक है. And 1 otherwise. Of course you can write it in the other form as well. It is 1 if object I is in cluster j, otherwise it is 0. मतलब यही है कि जो सो इन एसेंस जो हम कॉस्ट फंक्शन इन वर्ड्स में लिखूं तो ये क्या है, दिस इज सम ऑफ डिस्टेंसेस ऑफ ऑल ऑब्जेक्ट्स within within clusters in a clustering. ठीक है, तो एक ऑब्जेक्ट था, उसके अंदर जितने भी पेयर वाइज सिमिलैरिटीज है उसका सम है, पेयर वाइज डिस्टेंस का सम है, सिमिलैरिटी नहीं डी है, डिस्टेंस है। ठीक है, सो तो लेट्स से आपके पास दो क्लस्टर्स हैं, इन सारे लेट्स से सारे ऑब्जेक्ट के पेयर वाइज डिस्टेंस इसका सम पर इस इन दूसरे ऑब्जेक्ट का सम एंड टोटल इनको सम करेंगे, दिस इज योर कॉस्ट फंक्शन सी। ठीक है, सो ऑब्वियसली ये छोटा होगा तो इसका मतलब है कि छोटा होगा, दैट्स व्हाट वी वांट सो दैट ऑब्जेक्ट्स विद इन ए क्लस्टर would have low or small distances or dissimilarity, and objects between clusters should be high dissimilarity. So आपका जो k मींस एल्गोरिथम है बेसिकली मिनिमाइजेस c। ठीक है, so it minimizes c, so this is an optimization problem. And as I said, the optimization process or technique or the general technique that it uses is the expectation maximization algorithm. ठीक है, सो इन आवर केस हमारे पास जो ऊपर था, हमारे पास क्लस्टर C1 जो था वो 5 5 10 और 5 5 8 और 10 था, और इसका मीन हमारे पास था 7। ठीक है, इसका सम ऑफ सिमिलैरिटीज क्या होगा, बेसिकली 7 - 5 प्लस 7 - 5 प्लस 8 माइनस सॉरी प्लस बेसिकली 8 - 7, एब्सोल्यूट डिस्टेंस लेना है तो आई एम पुटिंग द बिगर वैल्यू बिफोर, प्लस 10 - 7। ठीक है, तो ये इसका इस क्लस्टर का होगा, दूसरे क्लस्टर का था C2 हमारे पास था, उसमें ऑब्जेक्ट से 12 और 15, और इसका सेंटर था 13.5, सो इसका होगा 13.5 - 12 प्लस 15 - 12। तो ये दोनों का आप क्लस्टर्स का ले लें, दिस वुड बी योर सी, सी वुड बी द सम ऑफ बोथ ऑफ दीज टू। तो ऑफ कोर्स दिस इज द फाइनल ऑब्जेक्टिव वैल्यू, आइटरेटिवली पीछे से हम आ रहे थे, इसको कम करते आ रहे थे। इफ यू लुक एट माय एग्जांपल बिफोर, और हर एक आइट्रेशन के लिए ये निकालें तो वो पीछे वाली ज्यादा होगी, आखिरी वाली थोड़ी होगी, सो वी आर एक्चुअली मिनिमाइजिंग दिस फंक्शन। So I think I will stop here. K-means algorithm is, as I said, is a popular algorithm. It's also a massively studied algorithm. The K-means algorithm was, I think, initially popularized in the 1970s, and since then it has been studied extensively. मतलब इसके ऊपर अभी भी पेपर्स आ रहे हैं, 70 से पेपर्स अब तक आ रहे हैं। थ्योरी इसकी बेतहाशा है, इसकी प्रैक्टिस बेतहाशा है, प्रैक्टिकल लोगों की इस पे ऑब्जर्वेशंस हैं, सो ऑन। सो देयर इज लॉट ऑफ स्टफ within K means। हम कुछ चीजें हम डिस्कस करेंगे नेक्स्ट क्लास में, एंड देन आई विल मूव ऑन टू द अदर एल्गोरिथम्स। ठीक है, सो एनी क्वेश्चंस? सो एनी क्वेश्चंस?
सर आवाज आ रही है आपको?
सो No questions?